Okay, let's get into this. You sent us a stack of sources, basically asking a question that sounds simple, but really isn't. What is math, really?
Hmm.
Most of us kind of absorb the idea that math is this, fundamental truth, the language of the universe, the bedrock for science.
Right. And your sources definitely acknowledge that traditional view. They talk about its power, its elegance, how well it predicts things. For ages, it's been seen as the ultimate way to understand reality.
Yeah, the idea that nature is somehow written in mathematical laws, abstract, pure,
Yeah.
seems to cover everything from, apples falling to planets orbiting.
Exactly. It's abstract, pure, seems to govern everything.
And that's the conventional wisdom. And honestly, for good reason, it works incredibly well for so much.
It does.
But here's where things get really interesting, because the main argument weaving through these sources just flips that whole idea on its head. What if math isn't the foundation at all?
Yeah.
What if it's something we made up, well, not made up, but developed, to describe something else entirely?
That's the really fascinating challenge in this material, yeah. It suggests math isn't the primary reality, but maybe a very sophisticated tool we use, a tool to grasp something deeper, more fundamental.
And the core idea we're going to explore based on these sources is this hierarchy. Motion is primary, then geometry is secondary, and math, that comes third.
It's a complete shift in perspective, isn't it?
Totally. It's not numbers driving reality, but reality. Reality in motion,
Right.
generating patterns that we then label with numbers.
Precisely. So it shifts the focus from, static equations and quantities to dynamic processes to rhythms. Our goal for this deep dive is really to unpack that viewpoint and see where it leads, how it changes, how we understand, well, maybe everything.
Okay, so let's start right there. The world isn't fundamentally built on math. The sources argue, pretty compellingly, I think, that the universe just operates. It doesn't need to crunch numbers to do its thing.
Well, think about it, right? A river flows down a mountain. Does it solve differential equations to figure out its path?
No, of course not.
Or a cell divides, tracing these incredibly complex paths. It's not running algorithms. Or, a photon zipping across the cosmos following space-time curvature. It does that through its inherent dynamics, not by doing calculus.
They just do. They move, they interact, they change.
Exactly.
And the sources really stress this. They do it in rhythm, following these dynamic processes, which points to motion itself being the sort of fundamental layer of reality, the universe always becoming.
Yes, motion happens first.
Mm-hmm.
That's the primary fundamental aspect of reality, according to this material.
So, okay, if motion's first, where does geometry fit? Because we usually think of geometry as, perfect shapes, static forms, like triangles and squares just existing.
But the argument here is that geometry is essentially the trace of motion.
Yeah.
Or maybe a snapshot of it. It's secondary.
Explain that a bit.
Well, take a circle. What is it, really? It's the continuous path traced by a point moving at a constant distance from a center.
Okay, yeah. Motion creating the shape.
Right. Or a straight line is just motion in one steady direction. Even really complex shapes, you can start to see them as the patterns left behind by movements interacting.
Okay. So it's like watching the pattern left by skaters on ice, rather than focusing just on the skaters. The geometry is the pattern that emerges from the movement.
Exactly. Geometry is frozen motion, as one source puts it quite nicely. It's what you get when motion kind of echoes into space and leaves a form we can see and measure.
Okay, that makes sense. Which then brings us to math, coming in third place in this model. If motion is primary, geometry is the secondary pattern. What's math doing?
Math, in this view, is the symbolic language. It's the thing we humans developed to describe those patterns, those geometric shapes, and the motion that created them in the first place. It's our attempt to quantify, to categorize, maybe predict, based on the traces left by reality's dynamic flow.
So math isn't the inherent structure of reality itself. It's our description of that structure, a tool, a very powerful tool, like a map. But it's not the actual territory.
That's a great analogy. It's like using latitude and longitude. They're incredibly useful for describing a journey, right? But they aren't the journey itself, the movement, the changing view, the feeling of the wind.
Right. You lose the experience if you only look at the coordinates.
Math takes the universe's inherent rhythm and dynamics and translates it into a form we can read. Numbers, symbols, equations. We don't need math to throw a ball.
Sure.
But we can use physics, which uses math, to describe its arc after we've watched it move. We observe the motion first.
Okay, so if math is a tool we created to describe this structured motion, what does that mean for how we've been using it, especially in science?
Well, this is where the sources offer a bit of a critique. Legacy science, which is often really rooted in that math-first perspective.
Right.
It tends to assume that if you can describe something mathematically, then that mathematical structure must be the fundamental reality, or that finding the right equation is the same as finding the ultimate truth.
But this view flips that completely. It says if you can describe something through its dynamic process, its motion, its rhythm, then you know it's real in that fundamental sense. Math just comes along later to model it.
Yeah, the reality is the dynamic action, the process itself, not just our quantitative label for it.
And this shift, they argue, might help explain why some things seem really hard to reduce purely to math. Things like consciousness, meaning
Right.
our subjective experience of time passing.
Exactly. You can describe, say, the firing patterns of neurons with math, right? We do that all the time.
Mm-hmm.
But does that equation capture the feeling of seeing the color red? Or the feeling of being in love? The sources suggest maybe not, or at least not fully.
And why not? What's the reasoning there?
Well, the reason proposed is that these things aren't simple, static, or purely linear phenomena. They're deeply dynamic, they're adaptive. They often involve really complex recursive feedback loops.
Loops within loops, systems interacting with themselves and changing because of it.
Precisely. And traditional math, which was largely developed to describe external things, predictable motions, quantities, it often struggles with that kind of self-referential, evolving complexity.
Yeah, you can't really write a single formula that captures the entire experience of, say, a Beethoven symphony. But you absolutely feel its dynamic flow, its structure, its rhythm unfold over time.
But, and this is important, the sources aren't saying we should just, ditch math altogether. Not at all.
No, that would be crazy.
It's still essential, but its role changes. It becomes less like the absolute dictator of reality and more like one very versatile tool, a powerful lens, but maybe one lens among several.
And maybe new kinds of math could even emerge, tools better suited to this dynamic view. The sources hint at things, concepts like sync arc for understanding the geometry of motion itself.
Or they touch on ideas like collapse field calculuses, which sound complex, but the idea is mathematical tools designed specifically to handle these complex self-referencing systems, these dynamic feedback loops.
So things that aren't just rigid sets of equations, but ways to model systems that are constantly moving and changing based on their own internal state.
Exactly. These wouldn't necessarily replace traditional math, but complement it. They'd provide ways to model reality that are perhaps better aligned with its fundamental nature, which this perspective argues is moving, rhythmic, process-based.
Right, pointing towards a way of understanding the universe more as a verb than just a noun.
That's a good way to put it. More as a process, not just a collection of static objects defined by numbers.
So bringing this whole discussion back around, pulling from your sources, the really powerful, kind of elegant conclusion they land on is the world isn't written in math, it's written in motion.
Yeah, and math is our incredibly sophisticated and genuinely useful way of tracing motion's path, describing the patterns, the shapes, the rhythms that motion inevitably creates.
Which means maybe we need to free ourselves from this illusion that numbers are the ultimate rulers of nature.
They're not, according to this view.
Rhythm, dynamic process, motion itself, that's what's primary. The world moves, it flows, and math, well, math follows along, describing the loops and patterns it generates.
The shift these sources propose is pretty profound, really. It's moving from seeing static numbers as the bedrock to recognizing that dynamic process and rhythm come first. Our math is derived from that reality.
Okay, so that leaves us, and you listening, with this final thought to chew on. If math is ultimately a tool, a language we created to describe motion and rhythm, does that fundamentally change how we should try to understand reality?
Does it mean the universe at its very deepest level is maybe more about dynamic flow, about relationships and processes, than it is about static quantities and fixed rules?
And what could that imply? Not just for physics, but maybe for biology, for understanding consciousness, even for how we understand ourselves, as complex, moving, rhythmic beings living through time.